So, hello guys, hope you are doing well. So, myself, Dr. Bapara. This is our lecture number 5. I am trying to provide you the basic electrical engineering subject. Okay, we are taking lecture of this subject. My aim is to provide you all the topics with minimum time and for the university exams. Okay, so for today's lecture, my topic is KVL and mesh analysis. So we have all okay. Before the last class was KCL, okay, and node analysis. So if you are following my channel, you maybe know that one. So this is lecture number 5. Let's first see what is KVL. This is the second law, okay, of Kirchhoff's second law. This is based on the law of conversion of energy. Okay, KVL, Kirchhoff's voltage law. This is mainly voltage law. What does it tell us? In any closed path or mesh, the algebraic sum of EMF and voltage drop will be equal to 0. Means total EMF plus EMF means, or you can say in any network, voltage source. Okay, total voltage source plus voltage drop I into R. Okay, voltage drop we'll see in numericals. Mainly voltage drop means voltage drop across the resistance. Voltage drop is V is equal to IR. Suppose here one example is a circuit is given across, suppose 3 ohm. Voltage drop will be V is equal to I into R. I, current flowing across or through this, current flowing through this 3 ohm resistor, I, okay, into R, the value of that resistor. Okay, so we can write this also. So what are the steps of mesh analysis? We actually uh, can write this KVL equation in mesh. Mesh means the smallest loop in a circuit under which no more loop can be present. Okay, all the mesh, we can call it a loop. The steps are very easy. Steps are: assign mesh current. We have to assign mesh current and we have to apply KVL at each mesh. Means we will assume mesh current in each mesh that can be anti-clockwise or clockwise both. Okay, that must be unit. Here we will go with the clockwise direction. Okay, here we assume clockwise. If you want, you can assume anti-clockwise direction, but it must be unique throughout all the mesh present in the circuit or network. Okay, so if you assume mesh current, this one, suppose I1, and we have to give name. This mesh 2 current is I2. Okay, this figure is given. The question is to find I prime. So from the figure, from the circuit, if the question is find I prime, that means we can say, if we can find the value of I2, this is the I prime. So our target will be, what is the value of I3, I2. This is the I prime value. Okay, this is the question. 3 ohm voltage source, 2 ohm, 2 ohm, 3 ohm, 6 volt, 2 ohm, 4 volt, and 1 ohm resistor is connected there. So First of all, assign mesh current. We have assigned. If you can provide the name, that is also good thing. Okay, try to give name. This is mesh 1 and this is mesh 2. In university exam, you need to write everything properly. Okay, maybe your final answer maybe may be wrong, but teachers will always give you step mark in university exams. So write everything properly whatever you are doing. So you have to write by applying. One more thing, let's before that, while we'll write this equation, total EMF plus voltage drop. In voltage drop, here sign will be a important thing. Okay, voltage drop, suppose we have one resistor and current is following through up to down side. Okay, this one is value R1 resistor, this one is R2 resistor. Okay, in both the cases voltage drop. Okay, voltage drop from the source value. Okay, totals we have a supply, total supply. From there is voltage drop. So always, if suppose current is following I here, here also I, in both the cases voltage drop will be IR1. So we'll write with minus IR1. Okay, here also we'll write with minus IR2. Okay, in the KVL equation. Okay, it will be clear to you when we write the KVL equation. And one more thing, suppose we have this voltage source. Okay, there is 3 volt, but I'll write here. This is actually the symbol of single cell. So suppose the voltage value is V. Here there is, what I change here, look, here the bigger line is upside, that means it's positive and it's negative. The bigger line is downside, it's positive and negative. Okay, both values are V, we are assuming. And suppose current is falling from upside I, current upside up to down, and here also current falling from up to down I. Okay, here we'll see it's coming from positive to negative, means bigger line to small line. Current is coming bigger line to small line, up to down. So we'll say that potential is decreasing. Potential is decreasing. So what we'll write, minus V. Okay, and here it's coming small line to small line is negative, bigger line is positive. Okay, small line to bigger line, the current direction is small line to bigger line, means we'll say potential is increasing. Okay, potential is increasing, small line to bigger line we are going, so potential is increasing. So we'll write in equation plus V. Okay, this will be clear when we will write here. So what is KVL? KVL is total voltage drop plus total EMF is equal to 0. You have to write properly. Okay, so write by applying KVL at mesh 1. write like this. Okay, always try to write like this, that you are applying KVL, and where at mesh 1. This is the mesh 1, we have given the name mesh 1 basis. Okay, so we will start from one component, any one component. You can start from any one component. So suppose if you start from 3 volt, so for 3 volt, look, current is direction like this, so down to upside, that means small line to bigger line. Okay, small line to bigger line means, small line to bigger line means potential is increasing, so we write plus 3 volt. Okay, then voltage drop, there will be always voltage drop in across the resistor. It does not depend on direction of current. Okay, here actually what we are saying, when it's coming positive line to positive to negative, or bigger line to small line, we are saying not voltage drop. Okay, it's decreasing, but here we are assuming when it's coming from the small line to bigger line, we are saying it's increasing potential. Okay, so for 3 volt we'll write 3 plus 3, because it's going from small line to bigger line, negative to positive means potential is increasing, so we'll write 3. Then 2 across 2 ohm resistor, across resistor there will be always voltage drop, and the equation is V is equal to I R, Ohm's law. Okay, R is given to, there will be always voltage drop means minus 2 into I. I is what? We have assumed the current I1. 2 into I1. Okay, then another one 2 minus 2 I1. Okay, then we have this 3 ohm resistor. This 3 ohm resistor is in between both the meshes M1 and M2, but we are writing the equation for M1. So here at this condition we will assume this I1 current is greater than I2. Okay, in this type of resistor you have to consider both I1 and I2, because this resistor is connected with both the mesh. There will be voltage drop across the resistors, so minus 3 into total current will be mesh 1 current minus mesh 2 current, I1 minus I2. Okay, then we have 6 volt. Here voltage is already given, we will just see the direction, what direction will give, plus or minus. It's coming from bigger line to smaller line, because current direction is like this. If we draw current, it's coming down through across this one, so we write what? Potential is decreasing, minus 6 is equal to 0. Okay, this is our first equation, plus 3. If you don't write plus, then also okay. 3 minus 2I1, you can directly write 2I1 minus 2I1, 2I1 minus 2I1 minus 3I1 minus I2 minus 6 is equal to 0. Okay, so this is our equation number 1. Then we can write 2I1 plus 2I1, 3 7I1, okay, minus 7I1 plus 3I2 minus, sorry, equal to 3 minus 3 is 3. You can write this one is equation number 1. Okay, then again we will apply KVL at mesh 2. For university exam, always try to write in details, because in many cases students may got the incorrect answer, okay, wrong answer, but if the steps are like properly written, teacher will always give you step marking. Then again, by applying KVL at mesh 2. Okay, mesh 2 equation, I think if you have understand the mesh 1 equation, you can write the mesh 2 equation. If you have not, let's see again. Let's start from this 6 volt. Okay, this 6 volt. If for 6 volt, like this one, the current is down to up. This current is assumed already. So down to up means smaller line to bigger line, means potential is increasing. Okay, so we'll write 6 plus 6, then this 3 ohm, again this 3 ohm is in between mesh 1 and mesh 2. Both the currents I1 I2 following through this resistor, so we have to consider both the current, but we are writing the equation for mesh 2, so at this condition we'll assume I2 current is bigger than I1, and this is the resistor, so there will be voltage drop, means minus 3 I2 minus I1. Okay, minus 6 minus 3 into I2 minus I1. So after that, 2 ohm resistor, that means there will be voltage drop. Voltage drop is V is equal to I into R. I is I2 and R is 2 ohm. So minus 2 I2. 2 I2. Then we have the 4 volt. Okay, we have the 4 volt source. For the 4 volt source, let's see the direction. Current direction is like this, means from up to down. Current is coming from upside to downside, means bigger line to smaller line, means potential is decreasing. Okay, so what we will write here? Minus 4 volt. Minus 4. Okay, then 1 ohm resistors. This across this 1 ohm resistance, what will be the? There will be voltage drop because it's a resistor. I2 into 1 means minus I2. Okay, it's equal to 0. Okay, so minus 3I2 minus 2I2 minus 3I2 minus 2I2 minus I2. Okay, 3 4 5 6 minus 6 I2, and I1 is, there is only plus 3 I1. Then 6 minus 4 is equal to 2. If you write it on the right side, minus 2. So this is our second equation. Okay, so we got two equations. If we solve these two equations, we will get the value of I2, because two variable I1 and I2, I1 and I2. Okay, if we solve this, we will get the value I2 is equal to, I2 value will get 0.15 ampere. Okay, 0.15 ampere. Try to write in university exam, try to write unit with the answer, okay, properly. So I think You have understand the first of all KVL is, so this I2 is equal to, this is our answer. This I2 is equal to I prime as in the question. Okay, this is our answer. And this thing, try to write at least minimum 2 decimal number. You can write 3-4 decimal number in exams, okay, but always minimum try to write up to 2 decimal number. Okay, so let's just revise the what we have done, what we have studied here. KVL is total voltage drop plus total EMF is equal to 0. Okay, and across these resistors there will be always voltage drop independent of direction of current, but through this voltage source there will be potential increment or decrease. Okay, if it is going from bigger line to smaller line, that means we'll assume its potential is decreasing. Okay, so we'll write with minus the value of this voltage source, we'll write in minus. This you need to keep in mind. And if we are going from, if the direction of current or mesh current is from small line to bigger line, that means we can say potential is increasing. So we'll write with positive sign. Okay, the positive sign plus V. So this is how, this is very simple. Okay, but in maximum cases, in complex numericals problem, try to apply KCL. If KVL is not mentioned or mesh analysis is not mentioned, because KCL is much easier. If you do the complex problems, you will see the KCL is much easier. Okay, and yeah, if you have any doubts, you can ask in my comment box, and our upcoming lecture videos will be on, I think, star delta. Okay, our upcoming video will be on the topic of star delta conversion. Okay, star to delta and delta to star conversion. That's equation only we will see. Okay, we will try to do numerical, but if we do numerical, maybe it will take with times. We'll see first the star delta equations. Okay, here maybe you can prove, you can prove these equations. We are not going that much deep on those things, because this proofs derivations never come in the university exam, and my aim is to provide you the topic or revise you the topics. Okay, for your university exam with minimum time. So bye bye for now. This is your lecture number 5. Let's see you in the lecture number 6. So enjoy your time. Bye.